Hey, all you mathematicians, welcome to the next section of Chapter 4. But before we get started, make sure you like and subscribe to my video channel. You gotta love what I'm putting out here, right? Just kidding. Do what you want. Hopefully your quiz went well yesterday. Today we're going to kind of expand on solving those inequalities. This section is about compound inequalities. So what that means is we're going to have two inequalities and we're going to put them together with either where they overlap or with just everything, put them together. Today we're going to be doing the intersection of two sets, so that's going to be like and statements for compound inequalities. So we're going to start that with the intersection of two sets. So we're going to use some fancy symbols here, but it's really not too hard. I'll show you what it is. An intersection of two sets A and B is the set of all elements that is common to both sets. It's denoted with this upside down looking horseshoe thing. So that's the intersection of A and B. So if you're thinking of it as a visual representation, if there are some things in A and then there are some other things in B, the intersection is what belongs to both of them, what's in both groups. So here is an example of that. If A is the set of x, where x is an even number greater than 0 and less than 10, and B is the set 3, 4, 5, and 6, we're asked what's the intersection of A and B. So first, this one up here is kind of vague, so let's put that in actual numbers. So let's define what A is better. X is an even number greater than 0 and less than 10. So that's going to be even numbers 2, 4, 6, 8, and it has to be strictly less than 10. So it can't be 10, so that's going to be the last number that's in A. So A are the numbers 2, 4, 6, and 8. B are the numbers 3, 4, 5, and 6. We're asked to find the intersection of A and B. So the intersection is going to be what numbers are in both sets. So it looks like 4 and 6 are in both sets. So that's going to be the intersection of A and B. So down here, we're going to practice that a little bit more. We're given 4 sets. We're going to put a couple of them together with their intersection. So again, A is all of the even numbers. B is the set of all odd numbers. C are the numbers 2, 3, 4, and 5. And D are the numbers 13, 14, 15, and 16. We're going to find first the intersection of A and D. So again, A is all of the even numbers. D is 13, 14, 15, and 16. So which numbers are in both A and D? Well, it would be those even numbers that are in D. So the intersection of A and D would be the 14 and the 16. Boy. If you want to try 3 and 4 now, pause if you want. Otherwise, I'll keep going. The intersection of C and B this time. So C is 2, 3, 4, and 5. B are the odd numbers. So what are the odd numbers that are in C? That'd be 3 and 5. And then 4, the intersection of C and D. C is 2, 3, 4, and 5. D is 13, 14, 15, and 16. So what's the intersection of C and D? Well, there's nothing in common with C and D, so we would say it's the empty set, or we can put no solution in the set. So there's some set notation. This is going to kind of build itself with compound inequalities. So compound inequalities that are containing and. Tomorrow we'll be doing or statements. Don't worry about that yet. So a value is a solution of a compound inequality with and if it is a solution to both inequalities. Also, if our graph ends up looking like this, we're going to write it in the compact form. So what these problems are going to be is they're going to be two inequalities. We're going to solve each of them, and then we're going to write a final inequality that describes our picture. So let's first solve the first one. All we have to do is add 7 to both sides of the equation. So x would be less than 9 on the first one. On the second one, it takes a couple of steps. First, you would subtract 1. So 2x is less than 8. Next, you would divide by 2, and x is going to be less than 4. Okay, so we've got our two solutions. So what I would recommend doing is we're going to draw a number line for each of those two solutions, and then we're going to find where do they overlap. And then, so on each of the number lines, I'm going to put the two numbers that we got. So 4 and 9 for the orange solution, and then second number line 4 and 9, because those are the numbers I got. And then I'm going to graph both of them. Okay, so on the pink one, I got x is less than 9. So that would be an open circle and shaded to the left. For my orange solution, I got x is less than 4. So that would be an open circle and 4 and shaded to the left. So our compound inequality and means where is it true for both, or where do they overlap? They overlap right here, right? Here they don't overlap, and here they definitely don't overlap because it's not true for either of them. So we're looking for where is it true for both? Where do they both get shaded? It's right there. So our final solution is just going to be the overlapping part. So it's going to be that open circle on 4 shaded to the left. So that means we're going to write an inequality that describes our final graph. So what does this graph look like? Well, it looks like open circle on 4 shaded to the left. So that's going to be just x is less than 4. That's where it's true for both of these things. So where do they overlap? It's x is less than 4. My final solution is x is less than 4 with that graph. Let's do another one. So again, we'll solve each of these inequalities and put them all on number lines. So let's see, divide by 2, x is greater than or equal to 0. This one we're going to add 1, 4x is less than or equal to -8. Divide by 4, and x is less than or equal to -2. Okay, I meant to do that in a separate color. Let's say that this one was orange. Okay, so my orange number line, I'm going to put the two values I got, -2 and 0. And then on my pink one, same thing. -2 and 0. Okay, so for my pink one, looks like I should have a closed circle on 0. And I'm going to shade it to the right. On my orange one, right, this one's orange, I would have a closed circle on -2. And I would shade it to the left. So for an and statement, I'm looking for where is it true on both number lines. I look here, it's only true on 1, here it's true on none, and here it's true on 1 again. So it's not, there's no overlapping like we had on number 1, right? Nowhere does it overlap. So this one is actually no solution. There is nowhere where it works for both of these inequalities. So this is going to be a no solution. In our graph, if you drew a graph, would have nothing on it. There would be no shading. Hopefully that's making sense. I've got a few more examples for us. Okay, so again, two inequalities. We're going to solve them both. This one, subtract 3. X is less than 5. The second one, add 1. 2x is less than 4. Divide by 2. And x is less than 2. Okay. So I would put 2 and 5. I'll go ahead and graph that one. I should have an open circle on 2, shaded to the left. For my orange solution, again, I will put 2 and 5 on it. And my orange solution would have an open circle on 5, and it would be shaded to the left. I'm looking for where do they overlap. Again, it's in this left portion right there. It's true, it's shaded on both of those. It's not shaded both of here. It's not shaded both here either. So I'm able to put that together for a final number line of 2 as my value, and I would have an open circle because it was an open circle. If it were a closed circle, I would have a closed circle, and it's shaded to the left of 2. So I need to put that answer as an inequality. It would be x is less than 2. The rest of them are what's called compound inequalities. They're two graphs or two things. They're just already kind of stuck together. So these ones are actually easier to graph. 4, 5, and 6 are easier to graph than 3 because there's no thinking involved. I know what the picture of these will always look like. So how you do this is you got to get the x in the middle by itself, and whatever you do to the middle, you have to do to the left and to the right. So if you just had, if you had this, 4 minus x is, or 2 is less than 4 minus x, what would you do to solve that? The first thing you would get rid of is that 4, right? How do you get rid of that positive 4? You would subtract 4. If I subtract 4 from the middle, I have to subtract 4 from the left and from the right. So those 4's in the middle would cancel. 2 minus 4 is negative 2. I have less than, I've got negative x, and then 7 minus 4 is 3. Okay, again, you can cover up one of them and say, what would you do to get rid of that negative? You would divide by negative 1, right? Or you'd say I would change the sign of one thing, which means I need to change the sign of everything. But remember, when we're working with inequalities, if you divide by a negative or if you change the sign of everything, you've got to flip those inequalities around. So this would be a positive 2. It's now going to be greater than. That would be a positive x. That would be a greater than. And then this one would be negative 3. Now this is out of order. Compound inequalities, final solution should always be less than symbols, and it should always go from smallest to biggest. If it doesn't, you've made a mistake somewhere. So this whole thing needs to be flipped around. So I'm going to put the negative 3 on the left, the 2 on the right, the x in the middle, and if I flip all of that around, that means my inequality's got to flip around with it. So it's going to go back to less than symbols, which is what we want. Now, compound inequalities are always going to be graphed the same. It's always going to be what I showed you there on the front. Compound inequalities are always going to be shaded in between the two values that you get. So, very easy to graph. You just make one number line. We don't have to worry about all of these number lines like we did them there. We put negative 3 and we put 2. These are open circles, and compound inequalities will always be shaded in between those two values. This would be the answer. This would be the picture. Compound inequalities are probably easier than the other ones. Okay, let's move along to number 5 here. I see that we have a fraction, so we know what our first step is. Our first step is to get rid of that fraction by multiplying by that common denominator of 3. Now everything's got to be multiplied by 3, so negative 1 times 3 is negative 3. Those 3's would cancel each other out, leaving me with the 2x. 3 times 5 is 15. And then 3 times 2 is 6. Okay, so again, you can cover up one of the sides and ask yourself, what would I do to get x by itself? Well, I would get rid of that 15 first. So how do you get rid of that 15? You get rid of it by subtracting. If I subtract 15 from the middle, I have to subtract 15 from the left and from the right. So those would cancel. Negative 3 minus 15 more is negative 18. Got my less than or equal to symbol. Got my 2x. I've got my less than or equal to symbol. 6 minus 15 is negative 9. Okay, there's only one more thing to get x by itself. Now we're going to get rid of that 2 by dividing. This time I don't have to flip anything around because I'm dividing by a positive number. So negative 18 divided by 2 is negative 9. I got x. And 2 doesn't go into 9 evenly, so we're just going to leave it as that fraction of negative 9 over 2. And compound inequalities are very easy to put on a graph. You just write them down like you see them. Negative 9 would be on the left. Negative 9 halves would be on the right because that's how they are orientated. I've got my less than symbol, so I know it's orientated correctly. These should have closed circles on them. And I always shade in between on compound inequalities like this when they're mushed together. Okay, 6 would be a great time to pause and try that one on your own, and then we'll compare answers after you've done it. Pause it here, try it out. Okay, so again, maybe you covered up and said, what would I do to get x by itself? The first thing you'd get rid of is that 5. So you'd subtract 5 from all sides. That would be negative 2 is less than negative x is less than or equal to 9 minus 5 is 4. Okay, again, maybe you covered up again. What would you do to get rid of that negative? You would divide by a negative, or you'd flip the signs and flip all of the signs. So I'm going to divide by negative 1. Those negatives would cancel each other out. 2 negatives make a positive. Oh, I forgot. I divided by a negative, so I have to flip my inequality. It's now going to be greater than, and greater than or equal to 4 divided by negative 1 is negative 4. This is not in the correct order because it's not smallest number to biggest number, and my inequality symbols need to be less than symbols. So it's going to be negative 4 over here, 2 there, x in the middle, and then this symbol should go with the negative 4 when you flip it around. That symbol should go with the 2 when you flip it around. And then we're just ready to put that on a number line, very easy. Negative 4 goes on the left, 2 goes on the right, just like the order it's in. It would be a closed circle on negative 4. It would be an open circle on positive 2, and still shade it in between. So let me know if you have any questions on that. Reach out to me, whatever you need to do, and good luck. Tomorrow we'll do the or statements, and let me know if you need any help. See you later.